All right, welcome everybody to Robot Builders Night Virtual for Tuesday, January the 14th. And we're going to do the usual roundtable for people who've got stuff that they've been doing and want to share with the club. And preceded by DPRG news and updates. And then we'll go to open mic. So DPRG news and updates. This Sunday, we're having for those in the Dallas area, we're going to have a theater evening. This is it's a new thing for we robot heads, but I hope a few people, maybe one or two people will come.
Say that again, Paul.
We're going to have a theater afternoon. So Mike Williamson will talk about this theater event that he's been involved in. He's built a couple of robots for it, and he's going to talk about them later in the program. But we're going to, as a club, hopefully we can get more than one of us, go and meet at on this coming Sunday, January the 19th at 4 p.m. in the Embarcadero building in Fair Park. And it's a immersive theater that delves into the universal truth that intolerance is intolerance. As far as I can tell, it's basically about about children affected by war, and it's an immersive theater experience. And what that apparently means, I've not been to one before, so forgive my ignorance, but Carl says they're pretty awesome. The actors and the audience all like intermingle, and the audience is welcomed and encouraged to be a part of the performance. And there are some number of scenarios that they will walk us around. So we'll walk between pools of light that have some kind of a vignette or story going on, and the actors will do their thing there, and then everyone starts together. We'll start at the first vignette or place and space, and move on to the second, and so forth. And so it's to go there. Let me just paste the link to it in the chat. Chat. There we go. So if you want to buy a ticket, you click on the date, January 19th, 4 p.m., and you click get tickets, and if you don't have an account, you'll need to create one. And then they're like $25, which covers admission and parking. And that's it. So I'm not going to take questions. I'll defer questions to Mike when he joins later on. But that's this weekend. Second DPRG announcement. We need to pick a Roboama date, and I think the date that I want to declare. Let's see, is Doug in the call yet? Apparently not. But the date that I want to declare is the fourth Saturday in May, which, let me just unshare this. My computer is going very slow. Okay. Fourth Saturday in May, will be May the 24th. So I think we'll do Roboama, one of our 2 annual contests. This will be the indoor contest on May 24th. We may have a practice the month before, not sure. We'll talk about what contests we're going to run when Doug joins us. Okay.
Paul, that is the American long weekend?
Yeah, that's the only thing I'm thinking. There might be
is
a
it?
holiday weekend, but to
Oh,
me,
really?
that's somewhat irrelevant now. So
Oh, is that Memorial Day?
I'm thinking
That's-
so. But I don't have a counter in front of me, so hence that's why I'm sending that.
Okay, thanks for bringing that up.
The weekend before is the Canadian, it's our Victoria Day.
I'm not seeing. Hang on. Come on, calendar. May. Yeah, Memorial
that
Day is not
weekend.
going to be good.
It's not Memorial Day. It's just the weekend of.
Weekend of, but people tend to go out of town for Memorial Day.
Mhm.
I wonder if we should hold it on the 17th then. I'm reluctant to push it further because I leave town on the 31st. Not that I'm an essential competitor, but I'd like to compete. And
Thinking that'll work, but I have some
So
kayak
what day, Paul?
in May.
what's that?
I'll be back in a moment with the calendar. Y'all discuss dates.
Yeah, okay. May 17th. Okay, and maybe we'll move because we'd normally hold it on the date of a monthly meeting, but maybe we'll move the monthly meeting a week earlier in May. I think that's probably going to be best. All right. Thanks to whoever caught that. All right. So with that out of the way, I don't think there are any other. Oh,
So what about the 31st?
we could do that if there's a preponderance of support in the group for that.
Because I have a calendar in front of me now, and Memorial Day is on the 26th.
Yeah.
So effectively, it's the 25th. So I would say 31st offhand.
Well, doesn't work for me, but let me take a straw poll here among those present. Let's see if you could raise your hand for one or the other date. So see that little hand icon down in the row of icons at the bottom. So raise your hand if you prefer May the 17th, Saturday, May the 17th for Roboama. I'm seeing 3 raised hands. Is that it? For anyone else can't find that, wants to, I might put this out on the list as well, but I'm just want to take a straw poll. Okay, so that's
Tom, are you good with the 17th?
I'm good
Yeah,
with the 17th. Oh, I can't do the 31st. I'm flying off to the Seychelles on the 31st.
Okay, well, the question is, how many people have a problem with the 24th then? I mean, I grant you it is Memorial Day, but right now I don't have anything scheduled for that weekend.
Okay.
So we'll go back to the 24th question.
So we had 4. Okay, so let's see. Raised hands for the 24th. We've got 5. That's the leader so far. 6, 5, 6 for the 24th. How about the 31st? Let's have a show of hands for the 31st.
Can you vote twice? In other words, that would be sort of set in choice, but I rather, yeah.
Actually, I didn't vote, but I'd go for the 24th. So, all right, let's declare it for the 24th, and the heck with Memorial Day.
Right, and we'll just adjust accordingly.
We'll have memories of robots. Okay. 24th. All right, with that, let's move into what people have been doing. And so I just want to share, let's see, you might want to pin me to my screen, pin me to your screen. And so I've been working on MiniBot.
Paul, do you have anything to announce about monthly meeting and voting and all that kind of stuff, or is that already been taken care of?
Yeah, sure. Thanks, Kareem. Yeah, let me do that. So the DPRG annual. Oh yeah. There's lots of stuff there. Okay. Thank you, Kareem. My computer is going so slowly at the moment. So the monthly meeting will be on the 4th Saturday of this month, which is the 25th. So it's not this Saturday, but the following Saturday. It's the annual members meeting, and it's where we will vote in the board members. We do have a slate of board members. So I'm running again for president. Carl is willing to stand again for vice president. Doug for secretary. Steve for treasurer, and John for librarian. So that will be, so the meeting will start at 10 o'clock Central, or 10:15, give or take. And the president for the last year, myself, will give a summary of the things that we did this last year, which we did a lot. I was tallying it all up, and we really swung right back into it this past year. And so after the election, we will then hold a discussion on a proposed change to the DPRG bylaws. The proposed change would eliminate the position of librarian and replace it with a position of information officer. And so we'll have a discussion first and take a straw poll at the meeting, and decide if the people at the meeting are supportive enough or not supportive of this proposal to basically get ourselves an information officer onto our board. The rationale for it is that there's a lot more in our online systems and in the value that the club brings to its membership through things like this Google Meet, RBNV meetings, the website, the Discord, Facebook, Meetup. It just goes on. There's just a lot of stuff there, and the board feels that we ought to have someone responsible or charged with keeping these things all going and making sure they're all administered, have administrators for them. So the IT officer would not be the administrator for all the systems, but would be responsible for making sure that administration happens, that they work. And then after that, we will have lunch, and then we'll have a panel discussion on cameras, and several people from this forum, including Tom and Doug and Ray and maybe Iron Rain, and I'm not sure I'm sure I'm missing leaving someone else. Oh, myself. We'll talk just briefly for a few minutes about a camera that they have experience with. Smart cameras we're talking about here. So not your dumb camera, but things that can run AI or stereo vision or things like that. Let's see, did I cover everything about the monthly meeting, Kareem?
Yeah, I think you got it.
Okay. Any questions on that?
Just what was the date again and the time, Paul?
It's the Saturday week, so January the 25th, beginning around 10:15 Central Time, and it being the members' meeting, we always have a after the elections and after the discussion of the bylaw change, we always have brainstorming for what shall we do this next year? What do people want to see? Do you want more talks? Talks on what? More of whatever. It's an open forum, so that will happen as well. So it's going to be a busy meeting. So we'll have to try and keep rolling on that. Okay. Rolling over to MiniBot. Are you all seeing MiniBot here?
Yes,
Yep.
seeing your drawing, your model.
Yeah. So I was very fortunate to be the beneficiary of a design review with Doug and Kareem, and they spotted lots of things that I didn't know about and were missing in the design. So I've made a bunch of changes since last week, among them putting in a bunch of stiffeners. I think I might have gone a bit overboard here, but it's fairly sturdy, and it's got a Raspberry Pi underneath a WaveShare general board controller for robotics for robots that sits behind a spinning LiDAR, which actually doesn't. The outside doesn't spin. The spinning bit is inside behind a window, and Oak D light on the front. And so the big advance for me was
Is that a battery box on the bottom?
Yep, battery box on the bottom.
Good. Keep the weight down low.
Yeah, it's actually got a ton of weight down the back. The caster is actually off center to make room, because the battery is kind of long, and I couldn't find any other place to put it other than down the bottom where it wouldn't impede access to the Raspberry Pi. And then the IMU is down on the left front. Oops, stop. IMU is to the left of the LiDAR. Doug had a neat tip. He said, put a centering knob on the front, and then you can put different, like, sensor bars or bumpers or different kinds of things that you would that would center themselves on that bump, and you would bolt it on here and on a matching hole on the missing panel because I forgot to extrude this one corner. So yeah, that's that. So the big excitement is I printed that out and started assembling it. And so,
Rapid prototyping.
yeah, right.
Yeah.
I appreciate your tips on getting all this going, Kareem. And so this is a little LiDAR. It's a cute little LiDAR.
Yeah.
No spinning thing. It's in behind this window. And so the Raspberry Pi at the back, and the IMU will go up front here. The OAK-D light sits along the front here, and underneath the battery will sit in this slot out down here. So it's coming along. I'm very excited. The WaveShare controller board arrives tomorrow. So I've had the motors and wheels spinning, and they ran. So hopefully I'll get some more stuff. I did try to get micro ROS so that they run. This is intended to be a part of an instance of Lino Robot. Lino Robot is a micro ROS based system that runs ROS2 on a Raspberry Pi or a PC, and micro ROS under Arduino on an ESP32 that sits on top of the Raspberry Pi, and it's supposed to be capable of SLAM. So my real major goal here is to get the robot running that stack and able to run SLAM to where I can make it run around a room or set of rooms and map them, and then use the map to tell it to navigate between rooms, and so that's it's all fairly black box stuff to me. So I hope it's going to work, because I don't really know how to debug this stuff or how it really works in its guts, but we'll see. So that's progress on MiniBot. If no one has any questions, Tom, do you want to tell us where you've gotten to? Because you've been doing some pretty advanced stuff.
So, Paul, are you the one designing just the 3D version, and what about the firmware design?
Great question. So let me share a couple of. Oh, actually, I won't share it, but maybe I will. But let me paste in the Lino robot links. So there are two links that matter. One is the ROS2 link, and that is here. And so this is the software that runs on the Raspberry Pi. Basically, what the Lino robot folks have done is put together a canned set of packages that do what you need for ROS2 with a microcontroller. that's running with a microcontroller running micro-ROS.
Mhm.
So let me paste that link in.
Oh, that is very detailed documentation right there.
That's what?
That's a very detailed documentation right there.
Yeah, and that I like that about it. It's there's one more link that I think is worth sharing. So Lino Robot, it uses all the good ROS stuff, ROS2, Nav2, and then here's the microcontroller with the running micro ROS. But they give you a recipe with a set of supported lidars and cameras. You can go outside of that list, but you're obviously responsible for integrating all of that if you do. They give you parameterized URDFs to where you can just plug in the things like the robot width and length and wheel size and all the stuff that you would need to put in a URDF to visualize the robot, and then Arviz and Gazebo supposedly work. Now I've tried to get Gazebo working and been unsuccessful so far. The other site, Lino Robot Hardware, is for what runs on the microcontroller. And so they have a list of, again, supported motor driver types, IMU, how to wire it. And in particular, one guy has done, they only support the teensy, and so this guy called Thomas Chu, who hangs out in the personal robotics Discord server, has put together, has ported the Lino Robot hardware repo to support the ESP32. And so I've been going down through his code and was trying this morning to get MicroROS to talk to the MicroROS agent. So here he build the MicroROS agent, and then you start it up, and supposedly I got this far. I got the screen output that said the MicroROS agent had started and it had created a topic and a publisher, and so all of that looked really promising, but I wasn't getting any data out of the nodes, and so further work to do on that. He also supports and recommends Jazzy, so that's Ubuntu 2404 with ROS2 Jazzy. I'm currently on 2204 with Ubuntu 2204 with ROS2 Humble, so I might be behind the power curve on this. So anyway, my hope is to blaze this trail and find out if the documentation is correct, if this stuff really works, and if you can actually reasonably easily build yourself a little two-wheel robot, such as I've just shown, and have it run around doing slam.
Interesting. Thank you.
I've got I've got one of the WaveShare little rovers. It's running Jazzy with the Pi 5. So it does work fine, and it also has that same driver board on it.
And you're running Jazzy on the Raspberry Pi?
Yes.
Cool.
Natively, not in Docker.
Yeah. Yeah, so I might be upgrading my laptop to 2404 soon, which I want to do anyway. So that's all I had. Any other questions, comments? If not, we'll move to Pat.
Or to Tom.
I always say Pat instead of Tom. I'm sorry, Tom. I don't know why I do that.
I'm
I won't take offense to it either.
Paul and I were emailing this morning when he asked me to help with the monthly meeting presentations. So I sent him an update of what I've done in the last week, and he said, "You got to talk about that." So here we go. I'll share just one photo or one image of the display I'm using on my cone object detector, because there's been a few updates in the last week on what I've done with that. I assume you can see that picture.
Yep.
Okay. At the time that I presented this last week, we had some discussion about why the centroid and the bounding box doesn't seem to represent the cone very well. This image is the actual image used by the machine learning inference engine in order to attempt to identify the cone and where it is. And it was bothering me why it didn't seem to do the kind of job I expected it to do. I expected the centroid to sit in the center and the bounding box to outline the cone, and it doesn't do that. It turns out that the centroid had a simple math error when I computed where to put the rectangle, the height and width. This is the W and H over here. So I fixed that error, and that still didn't solve what's going on here. So after some more research, I realized that the edge impulse framework system, which I use, and which I tell it I'm running this on an ESP32 cam, it recognizes its relatively low performance and does not have the horsepower to run a full neural network inference engine. They happen to prefer to use MobileNet version 2 modeling, although they will use others. But that simply won't run on an ESP32. So what they do is they implement a FOMO model, which is a subset of machine learning implementation. And basically what that does is it only produces a centroid. It doesn't produce bounding box information. And it dramatically reduces the granularity of the image that it processes. By default, their FOMO model uses what's called a cut rate of 8, which means that my little 60 by 60 pixel image gets divided by 8, and the granularity becomes the equivalent of a 7 by 7 pixel instead of a single pixel. They then process that, and because my cones tend not to be very big, the information they provide turns out to be the number of these little 7 by 7 granules that come out of the FOMO model, which happen to be 7 by 7 pixels in size. So in this implementation, they decided there was only one little granular element, and they didn't find it for the whole cone. They don't use particularly precise modeling. They effectively build what's called a heat map to try to represent where they think the object is. And they tend to put the centroid, the center of this square, the centroid tends to go in the upper left-hand corner of where they think the object is. Hence, in a lot of the images that I was testing with, the centroid tended to be in the upper left-hand corner. It's not always there. Sometimes it's closer to the middle, but it's usually in the upper left-hand corner of where the cone is, and I either get a 7 by 7 box or a 14 by 7 box. So that was an extremely interesting discovery. If anyone wants to know more about FOMO models, which stands for faster objects and more objects, the Edge Impulse website has a really tremendous, understandable paper on what FOMO models are and how they design them. I did attempt to reduce the cut rate that's used in the FOMO model from 8 to 4, which makes the granularity 4 instead of 7. But what that did was it significantly increased the execution time of the inference engine from about 300 milliseconds to over a second. And it also reduced the overall accuracy of the model's detection from about 93%, which is what I'm getting with the model I'm running, down to about 76%. So that was not the right way to go. I also have started to take a look at how to improve the picture quality. I'm using an OV2640 camera which is the standard digital camera supplied with, or that used to be supplied with the ESP32 cam units. It has a number of very complex capabilities, including auto exposure control and auto white balance and auto gain and a bunch of other stuff, some of which don't work particularly well, especially if the lighting conditions aren't really good. There are a number of other people who have taken a look at this stuff and have identified the fact that you can extract a light meter equivalent number from the camera's controller, essentially a luminance value, and you can use that to write your own auto exposure control. So I've started to take a look at that. Others who have done it indicate that they can get much better auto exposure control. Now, the big issue that I found with the auto controls is that although my model in simulation runs every 300 milliseconds, I've also added actual measurements. Because I've added a lot of code to the main line, my model is actually running about once every 500 milliseconds. But every once in a while, it will take 2 or 3 seconds to execute one loop. And I finally pinned that down to the behavior of the auto controls in the camera, which I was quite surprised by. And other people have identified the same problem. So I'm kind of motivated to see if I can make my own auto exposure control work. It's not working yet. It's unstable. But we'll see if that works. And if so, then I may get a little better control of this thing. We'll see how that works out. The fact that I'm not running quite the same machine learning model I thought I was got me interested in taking a look at a little better, a little higher performing MCU. So I did a little survey. I put together a little survey of a dozen or so of the typical smart cameras that would be appropriate to both cone detection and the kind of budget I like to use on my hobby, which means not very expensive. Let me just switch to another sheet here. Stop presenting. Let's find something else. Window. This one right here. So one of the things that I ran across in my little survey of a dozen systems, you can see this one, I assume. Let me switch so I can see it. This is a Seed Studio Grove Vision AI module, the version 2. 16 bucks. And I looked at it and thought, okay, the price is right, but does it actually do anything? So then I ran across a technical presentation at an ARM developer conference from a couple of years ago, which compared the performance of what's called the NPU, the neural processing unit, which is on board this little Grove unit, along with some ARM processors. It compared its performance with an ARM Cortex M7 running at 500 megahertz, and then 2 different models of the neural processing unit that happens to be in the Grove. The neural processing units ran 2 of this presenter's real-world machine learning models between 30 and 100 times faster than the 500 megahertz M7, ARM Cortex M7, was executing the same models, which I was just astonished by, considering the kind of price difference here. So I suspect I will probably pick up one of these along with a camera. This price does not include a camera, but cameras are $5, and this thing will support a dozen different cameras. So this looks like something I may try. This is supported by my preferred machine learning training tool, the Edge Impulse framework. They already support this thing, so I'm quite pumped by the possibility of doing this. If I wasn't going to get one of these, just for the sake of reference, the next choice I would pick would be MaxCam Pro, which is the camera version of the MaxCam stuff, which also happens to have a neural processing unit on board. I don't know which one. I don't know anything about that yet. It's substantially more expensive than this, though. Anyway, I think that was probably it. Did you have any other questions?
When you say MaxCam, is that the MAIX cam that
Yes,
the Ray is using?
Yes, it is. It's the one with the actual camera and a hell of a lot of performance on board. It's got really, really powerful MCUs on board. Plus, it has an NPU.
Tom,
It's
is
a
it
good
free,
deal.
is it supported by Edge Impulse?
I did not look up the MaxCam to see if it was or not. I only looked up the Grove unit.
I
You can
couldn't,
look
I
up pretty
couldn't
quick.
find the Edge. It's supported by Edge Impulse,
Yes.
and so that was I was a little disappointed with that. I've been using the Max Hub to program it, and I've had decent results. Not as good as I would hope, but I also have one of those Grove Vision AI module V2.
You have
So
the version 2. Yes. Good.
I
Good.
have one. So I may try that on Edge Impulse and see if I have any luck, because I didn't with their standard cone model that they had pre-trained.
Right.
I was not getting anything at all on it.
Okay. Which camera have you got with the Grove?
It came with it.
Okay.
Uh,
So it'll be a 3 megapixel camera, I think.
It's a Raspberry Pi camera Rev 1.3.
Yeah. Yeah. Okay. And did you get the ESP32 that plugs into the top of it?
I do have the ESP32 that plugs into the top.
Yeah.
So I have that as well. So the ESP32 Sense module.
Yes, that's right. Yes, it looks to be quite good. I wondered, does anybody else in the group have one of these Grove units? No. And Pat, your MaxCam, is that the MaxCam Pro?
No, it was the version before it. So it's the Max Cam, not the Max Cam Pro.
Okay.
I don't know what the difference is between the two.
Yeah. It's the speed of the CPUs and whether it's got an NPU or not.
Yeah. So what I'm finding is that it's just a lack of software, to program it. That's been a little bit of a hindrance.
Okay.
You can't get enough information out of it. So you get like a confidence level of 60, but you don't know what's going on. So that's where I've been digging a little more into it, but it still seems to be very limited when you're trying to troubleshoot why you're not getting better results.
Yeah. So have you tried the Edge Impulse framework yet?
I just had a look at it, but I could not find that it supported the MaxCam.
Okay. I'll have a look also and see if it does. Just as an example of why I continue to think it's so good, when I realized that I had a FOMO model running on my ESP32 cam, and I decided to go in and try to modify the cut level for the FOMO training, I went into their tool set. I had to get into the expert mode, but I went into their tool set, and 20 minutes later, I had another complete model to test. And their simulator tested it for me, and I could compare it with the other models I had already done, which they save in their in my benchmark account. I was really impressed, and I haven't used it for 2 or 3 weeks, and I'm getting old, and I tend to forget how stuff works. But 20 minutes later, I had a complete separate scenario tested. It's really impressive.
So did you splurge and update to the paid account?
I haven't needed to do that yet. I'm still living with a max of 3 experiments, but that's all I need. I've never hit the time limit for training. I might if I have a bigger processor, but you're probably likely to hit the time limit if you have a more complex set of objects you're training for and bigger picture images. I'm using a very small picture image, 60 by 60. I don't know what their upgrade costs are.
I'm not sure either. I just noticed that if you wanted to do more than 3 experiments, you needed to upgrade.
Yeah, if you want to keep them simultaneously in their structure, or you can download them and load them back up again.
Yeah, on Max Hub I have, which is essentially no charge. I have 4 or 5 different versions. So all with pictures loaded for each one separately, sort of stuff like that. So
Yeah. Are you the only one in the group with a MaxCam system?
I think Ray has one as well.
Ray does.
Yeah.
I think Doug's got one too.
And do you have the Pro or the older one?
The older one.
Anyway, that's all I've got. Thank you.
Thank you, Tom. Boy, you're just charging ahead with in all kinds of areas. From
Well, I'm doing my rapid prototyping, but it's far less impressive than yours. It's just a box for my camera.
Let's see, Fernando and Iron Rain, are you guys ready?
I believe we should be, Anuhya.
I'm good to go. Do you want to start sharing or should I?
You?
All right. So, I don't know how many of you recognize us, but we've been here a couple of times every so often. We're Iron Rain, and so this is the start of another season compared to last year. And we just had we would just wanted to share like a couple of our updates with you as we like continue trying new things with our robot. And we wanted to get some advice from y'all because we know y'all have been doing robotics for so much longer than we have, and it's a really valuable resource. So I'm going to start sharing in a second. And Fernando's also been here once before, but just let him get another opportunity to introduce himself. I'm sorry, I'm having a bit of an issue sharing.
Well, hello. I think I introduced myself a little earlier in the meeting. I'm Fernando, sophomore in high school, first full year on Iron Rain.
So, I don't know if we've explained our game to you before, but for those of you who don't know, in FTC, we design a robot that basically tries to accomplish a certain set of challenges. And this is our game field this year. So as you can see, there are a couple different zones and there are two different alliances. There's a blue alliance and a red alliance. And you work alongside another robot to accomplish a certain set of goals. And this year it's getting samples into the net zones. So the pieces in the little rectangle you see in the middle, those are called samples. And we're trying to get them into buckets in the net zone or just in the net zone. Or we're trying to get specimen, which are samples with little clips on them, to hang on to little rungs. And I'm going to explain that in detail in a second. So basically, that's our goal this year. So we're trying to accomplish a robot that can grab onto these little rectangular prism looking things and basically put it in these like goals where we'll be able to get points. So these are samples and these are specimen. This is the only difference between the two. And to get kind of like a view of like the point system, to score a sample in the low basket, that is 4 points. To score a sample in the high basket, that is 8 points. While specimen require a human player to attach a clip onto a sample, but they score 2 more points per. So every specimen scored in the low chamber gets 6 points, and every specimen scored in the high chamber gets 10 points. One quick nuance is that once a sample has been turned into a specimen, it can no longer be used as a sample. So if a specimen is scored in a basket, it scores 0 points. It's basically a waste of a specimen. And these are the submersible and net zones. When I talk about like high chamber, low chamber, or the submersible, that is what I'm talking about. And basically, this is kind of it's kind of like our sand pit for these samples. And our goal is to reach in, grab a sample. We are only allowed to control one sample at a time. Grab a sample and then deposit it into the location it needs to go, which is generally going to be the buckets. Or we're going to go to the observation zone where human players waiting ready for us with a specimen that we can grab with our robot. That's just a quick game overview, and that's just to explain kind of like what the robot we're trying to design this year is for. And we're going to move on to our current robot progress. So this is like the chassis of our robot from last year, and that has been repurposed for this year. Because one of our main goals this year was to get like a robot where we could get started with gameplay as soon as possible, because this year's game is significantly more focused on like getting points than awards in a way that previous games haven't been. So this is the chassis we're working with. It was designed for last year's game, which is why it looks kind of bulky. That's something we're trying to work on with the new chassis that we're currently designing. However, it's fully functional. It has a Mecanum drivetrain. It's a drivetrain that our coders are very used to working with, which is one of the pros of having a chassis that's simple like this. However, there are a lot of cons because once again, this wasn't designed for this game. So grabbing samples is slightly difficult because we're grabbing them from the ground and the arm hasn't been optimized for that. And it's very large and bulky, and this is a game where we need to move relatively far. There are movement restrictions placed on us. We can't spread out as wide as we historically have liked to. So having a chassis that's basically built to be pretty stationary and have an arm primarily moving around isn't the best idea for this year. So we want a chassis that can basically zip around. And that's one of the things we're working on. So this is the intake system, which you can kind of see in that little GIF there. It's the clear looking thing that's moving. So this is how we're intaking samples. So we realized that if we wanted to intake properly, we shouldn't just push the samples away from ourselves when we're inside the submersible. We want to pull as many samples towards us as possible. So that's where the concept of raking in samples came from. Also, I just realized I have my camera off. I'm sorry. That's where the concept of raking in samples comes from. So the sampler consists of polycarbonate walls with curved deflectors to stop multiple samples from jamming, because one of the issues we saw is that we were accidentally getting multiple samples stuck at the same time, so we couldn't control either of them. And then additionally, that also gives us fouls because we're only allowed to control one sample at a time. There's also a color sensor, which allows us to detect which sample we want, because there are 3 different types of samples. There are red samples, blue samples, which are alliance specific, and a yellow neutral sample. So we are trying to avoid capturing the samples of the opposite alliance, because once again, that will get us fouled. So we've also made a lot of mistakes with the sampler, and I'm just going to walk you through one of them, which was very, very recent. So this was version 3 of our sampler. As you can see, it was completely falling apart. It's literally being held together by gaff tape. And it was really hard to get any usable data from any of the matches run with it. So we started rushing into getting the next iteration of the sampler made. But because of the way it was constructed the first time, gaff tape was the only thing holding it together, and we wanted to get V4 out as soon as possible. But that led to us making a lot of mistakes with version 4 of our sampler, because we knew what worked from this version, but because we were so busy trying to get a new version out, we kind of ignored all the on-robot testing that we should have done. Or sorry, all the off-robot testing that we should have done. So in the process of making a more functional version, we rushed the assembly, and that led to even more issues in the long run. Our beater bar was too stiff, so we ended up pushing samples into the ground instead of guiding them with a sampler, because we were having weird temperature issues on our 3D printer. And then the angle connecting the sampler and the carbon fiber tube that you can see there wasn't right. It wasn't intaking samples properly, and it was putting a lot more stress on our coders. The color sensor was mounted too far from the wall, so once again, not very usable data from that. And the beater belt sprockets were not aligned properly, so they would basically fall off really regularly, making gameplay really unreliable. So then we had to basically go back to the drawing board, see what we could figure out with this. And we decided to cut notches into the beater bar tines, which you can kind of see in that left picture. And that makes them more flexible, so they can guide samples in more easily. So they're not just pushing the samples into the ground. They're actually like guiding them into the sampler. We realigned the color sensor, and we made the standoffs, which were acting like the color sensor mount, slightly shorter. So they were pressed up better against the polycarb. And we couldn't adjust the angle of the CF tube without printing a whole new part. And that's literally hours of printing and then reconstruction. So we decided to let the coders deal with it, basically. And so the lesson we learned was that testing off robots should be prioritized, because it helps us more in the long run, even if it feels like it's going to take more time then.
So here, Nia, could you play the clip? Yes, so this is the moment where there's this brand of servos, Axon. They're pretty expensive, but high torque. We have a record of breaking them in the past years, and here's the first one we caught live on video. So basically, when the arm was moving back, it got caught on the floor, and then we overstrained it. And there goes, I think, $50. But an upside to this
85. Those
Sorry?
are 85. Those are
Oh,
expensive
never mind,
servos.
85. Yeah. But there was an upside to this. since we've been very proficient at breaking servos, we've also gotten a little better at fixing our robot. I think this took us 30 minutes to get the servo off and then get a new one back on. And then this isn't a clip of the arm actually working after a while of it being messed up from all the previous jankiness. So that was pretty cool. And then for our current chassis, right now we have a single arm that is a 2-stage linear slide. I believe it extends to around 3 feet, and it's currently on a worm gear shoulder. However, initially we were planning on doing some kind of coaxial shoulder joint that would allow us to both extend the slides and also raise them up and down. And then we're planning on adding a second linear slide arm so that we can have both sampler and then another intake that we've been working on alongside it. And then this is bridge. This is the first version of our shoulder that was supposed to be a temporary fix, but we all know how permanent temporary things are. So we used this for a while. I think we took that to our first meet. It's using those high beams on the sides. String goes over them. There's pulleys on them, and then go down to a motor at the bottom where there's 2 spools. And then those strings are attached to our arm from the original chassis to lift it up, and it uses some GPU hinges. So that was nice, but it was still pretty jank and supposed to be temporary. So after that, we come to our worm gear, where I said we were going to do some kind of coaxial thing. Now that we've chosen to go with this NVRM worm gear commercial part, it simplified things a lot. We only have to use 1 motor. It makes it easier on code, and we can adjust it a lot more. This way we can get the actual angle of the arm a lot easier than we would have with something like a coaxial, which has to mess with both the linear slides and the actual pivot of the arm. Plus, it takes up a lot less space. So meet overviews. As of now, we've gone to 2 meets. However, we were supposed to have gone to a 3rd one this past Saturday. So here's how we did.
So this was the first meet of the season. We were kind of prepared. We had a consistent auton where we were scoring 1 sample in the low basket. And the mean cycle time for a sample was around 23 seconds. However, once again, because of coders having a lack of time with the robot, we didn't actually have that much time to finalize our strategy. The drive team didn't have much time to coordinate previously. And so we kind of made silly mistakes that we really shouldn't have been making, especially because we've had so many years of practice. But this is kind of when we started realizing that we really need to start prioritizing getting drive practice, on our own times, instead of just waiting for league meets to provide us a reality check. And unfortunately, in our second meet, it went downhill from there. There was no auton in any match because we just recently switched to a new arm instead of using that bridge that you saw earlier. We had switched to the worm gear, and we handed our coder this robot 3 hours before the actual competition and said, code it. And that didn't work. So the robot was essentially a push button every match because the main arm, which had the main end effector for intake, didn't work. There was also a servo issue where the sampler just wasn't responding to anything. So that was a bit of a problem, and we were just a push bot, which really hurt us because we were winning games just because our partners were carrying us through the games. But this also means we didn't get any high auton scores, which we need as tiebreaker points. So to put us, basically, there's a way that ranking works, and if you win a certain number of games, you are pretty high in the rankings. And then because a bunch of people have won that many number of games, auton points basically work as a tiebreaker. So we just don't have an option for that anymore.
There's
And
a quick way to explain that from the previous slide. So in the previous slide on meet 1, they won 3 out of 2. So they were 3 for 2, right? Yeah. So they won 3, lost 2, but they were at the very top of the list of the teams that won 3 because they had the highest auton scores. So within each rank, right, is your auton scores that that act as a tiebreaker. But in the second meet, 0 Auton scores, so they're at the very lowest for that meet.
And like a lot of other things, meet 3 was canceled due to the impromptu snowstorm. And we lost opportunities to win more matches, so we can't be seated high in the tournament bracket, which is how the placements in the tournament, which is the qualifier for regionals, works. We have Auton points that are low because the robot hasn't been match ready in the previous league meets, and now is the time that our coders are genuinely getting time to work with the robot. And we have been struggling with our sense of urgency, and we don't have the opportunity to have meet 3 as our wake-up call, where we pool in our effort and get our robot to a place where it can compete. We don't have that opportunity now. So now we have to be prepared for the tournament with significantly less practice than we'd have preferred.
Right. So now we're going to show you what we've been working on and designing for the next full iteration of our robot. And we hope to have had this all done, manufactured, built by tournament, but we are severely behind. So we're just planning on having it designed by tournament and then having it ready for regionals if we qualify, of course. So first of all, we have Speciminer. This is version 1 to version 3. Version 1 being the first ever proof of concept, version 3 being our current one. It's designed to work for both specimens and samples, so we have kind of a diversity in case something wrong happens with a sampler. So for V1, the proof of concept, we used all PLA parts, so it was pretty flimsy. There was also no kind of physical limits on the claw halves' range of motion. We only have 2 rollers, so there's minimal surface contact surface. Sorry, and then it's very structurally unstable because it was very much a rush job. This was, I think, designed in a few hours and built in a day. And then for the elastics, since we're closing this with kind of an elastic retention, we use surgical tubing, but that proved to be too weak for our use, and it didn't last at all. For V2, now we've upgraded to 4 rollers, so there's a lot better contact between the rollers and the actual block. Helped a lot. We're still using PLA parts, which is unfortunate. Now we have the servos actually mounted on, but they're weirdly mounted with the aluminum servo brackets it's a commercial part. And then now we've added a large pyramidal structure at the center, so it helps with the lining, and it also adds some kind of physical limit. And probably one of the bigger changes was changing to an extension spring, much stronger, and it won't loosen over time as fast as the surgical tubing, plus added another physical limit to the claw halves. Now we're on to V3. We've changed a few stuff. Now most of our parts, or at least the claw half plates, they're now we've cut them out of carbon fiber, so it's a lot stronger and lighter weight than using those servo brackets, since now they're built in to the halves. We've changed to go build a super speed servos. It causes intake and eject to be a lot faster. We're using custom printed TPU belts. This way we can replace them once they loosen. We don't have to go out and buy more or have some kind of tensioner. And then we've added a color sensor at the tip of the aligner. This way we can detect what color the sample is if we're choosing to do samples. And then we dyed our rollers black because they interfered with the color sensor, which we should have probably noticed earlier on. But it took us up to about now to notice. Oh, and then the 3D printed parts, they're now being made out of CoPA instead of PLA. So it's pretty good. And now Speciminer, pros and cons. Pros,
your materials made out of, your 3D printed materials made out of what?
CoPA. It's a type of nylon. It's a blend between nylon 6 and 6.6 from Polymaker.
Okay, thank you.
Mm-hmm. For pros and cons, it can manipulate both samples and specimens. So that's a pro it has over our other intake, and then a few other intakes that a lot of teams have done. Its intake and eject sequences are pretty fast, and we can automate them thanks to the color sensor embedded in the tip. And I mean, it just looks cool. It's black TPU and it's carbon fiber. Come on. For cons, it requires extra precision, especially compared to the sampler. It's quite bulky, especially compared to a lot of other intakes that teams have been doing, and we haven't been able to actually properly test it on robot or on a separate kind of testing chassis. We've only been doing tests like this with our hands, so no proper data. Now on to Swerve. I think we went over this during the summer at one point, and we had a test platform at Moonday, but we'll be going over it again a little bit here. We have a custom designed housing for our servo, and then custom mount plate for our motor. It's been designed to be easily serviceable both on and off robot in case something goes wrong, which please know. We're using a motor to drive the actual wheel, and then we're using a servo to control the drive or the yaw of the wheel with the belt. Then analyzing our Swerve pros.
Just for definitional purposes, so because Swerve is a standard in the FTC and FRC, high school competition worlds, I don't know that it's necessarily a standard name in robotics in general. But basically, the idea is that each wheel can be steered independently. So sort of like you see on some of the Mars rover type designs, those kinds of things. And so you need to have at least two in order to be able to steer a chassis, sort of working against each other, but you can have any number of them that you want.
About that, Mars rovers, I believe someone at Moonday had a little orange rover, used wheels similar to that, but not exactly since they're driven a little differently. Then for analyzing Swerve, pros, chassis doesn't have to actually turn, the wheels do it for it. So you won't see the chassis turn, the wheels do it on their own, and then you can just keep going in that direction. And it looks cool, carbon fiber again, and we're going to be dyeing the nylon red. Con, it's sacrificed, this version, it sacrifices a lot of strength and durability just for looks. So we've been working, or we're going to start working on making it a lot more durable, even if we have to sacrifice those looks. And most of the parts have negative tolerances or tolerances that are just too tight to be sustainable. So we probably want to change that as soon as possible. Now for our material choices, these also go into or go alongside whatever we chose for speciminer. Copier, all these tan colored 3D printed pieces you see, those are made of copier and nylon. Chose it for the great impact resistance, heat resistance, and layer adhesion it offers. We are using 85A Ninja Flex TPU. Softness, great layer adhesion, works pretty well for wheels, and then the carbon fiber, obviously for its lightweight, strength, and flexibility. Plus, it looks really cool.
Had a theme.
Yeah.
So this is our chassis. Of course, all this is very work in progress still, but this is what the chassis we're ideating looks like right now. This is going to be the version of the robot that we're hoping we're going to be able to take to regionals, assuming that we get in, hopefully. So it consists of a giant 4mm thick carbon fiber plate, the two swerve modules that Fern was talking about a moment ago, a servo power module, a Go Build a pinpoint odometry computer, and two sets of autopods under the robot and a pair of Omni wheels. And the reason for the really weird shape of the chassis is because we want to maximize maneuverability, which is why you can see those curves. And we wanted the triangle shape so we can pigeonhole the swerve modules inwards and we can take up as little space as possible so our coders don't murder us for not fitting inside the 18 by 18 by 18 inch sizing requirement. They get mad at us a lot if you haven't noticed. And additionally, we want to keep the swerves as far apart as possible because we wanted to, because that's just how they work the most efficiently, but we didn't want to make the robot off balance. And because of how heavy the back end is, we added the battery mount at the front because we're also going to add the whole shoulder assembly at the back. However, one of the problems we foresee is a balance issue. Like with the current robot, like the robot chassis that we've seen already, that's already pretty heavy. But we have seen that if you if there's acceleration when the linear slides are being raised, it will almost start to topple over. And we're trying to make this relatively lightweight. So we're really hoping that we can figure out a way to combat that, but we're not 100% sure. And also we're working on seeing what else needs to be added to this chassis design before we can start prototyping the MDF. So we have less mistakes, less tolerance errors, etc. before we start actually like progressing to a carbon fiber chassis and wasting like hundreds of dollars. And this is the incomplete version of our competition robot, Poseidon. So there are two arms with the speciminer and the sampler, as you can see here. The shoulder is lowered from the previous chassis to make intaking possible when arms are parallel to the ground, because in the current robot, the shoulder is pretty high off the ground because that's the most convenient place to mount the worm gear onto the back plate. So on this one, we try to make it as low as possible. So it's less effort for our coders. So all they have to do is essentially just extend the linear slides outwards, and then the elbow joint is doing the work. It's also a shorter chassis to increase reach into the submersible, because the plan is that we're going to push those Omni wheels up against the side of a submersible. And then all our arms have to do to get in is just extend, and then they'll have full reach and control over whatever area of the submersible they want to be able to go into. And then some things were, and also additionally, it's also kind of high, like the actual chassis base plate, the height off the ground is to maintain that we don't accidentally like control samples. They're supposed to completely easily roll under the chassis, so we don't get penalized for something like actually pushing them around multiple at a time. And we're probably going to add like some copier like guides alongside the Omni wheels, alongside the Autopods, so nothing actually gets caught up there, because our main priority is avoiding penalties. And some of the next steps we have is just getting that time management figured out, making sure we have that sense of urgency, because we don't have that reality check of the league meet anymore. I didn't explain this earlier. So if we go Okay, so if we go to this page here, if you can see the high rungs and the low rungs, basically those kind of work like a step ladder for the robot to climb in a part of the game. So in the end game section, so the last few seconds of the game challenge, one of the ways the robot can get points is to either be touching the low rung, to be completely sustained by the low rung, or to be on the high rung. So, however, there is a slight caveat to the fact that to be on the high rung, you have to have gotten there, like you can't initiate contact with the high rung without already being off the ground. So the first place your mind goes to, if you're not Mr. V, who's immediately thinks of a jumping robot, the first place your mind goes to is climbing the rungs. So that is something we're still trying to ideate and figure out. We have an idea, but we haven't actually done testing with it because we still don't have a robot with two arms on it. So these are all things that we're trying to figure out. And if y'all have any advice that y'all think could pertain to us, that would be incredible. And I also just want to kind of show you what I was talking about with that tipping problem. This is kind of what the robot will look like when it's when the arms have been like raised. This is without the arms extended at all. These each of the arms have a 2-stage linear slide and then that elbow portion. But this is kind of like what we're working with, and these are just some of the problems we're trying to figure out. Thank you.
Wow.
Yeah, make it jump.
You guys have some challenges.
So when you're going to have it, didn't you, one year or another, you had like one that would pull up, literally pull it with a rope up to the top of whatever the tower was? I keep thinking when you're saying you have to get extra points to get the robot on the top ring. So how are you going to achieve that? Or have you even thought about doing that?
So in the past, last year, we had a mechanism where we kind of just like ran into the the rungs full speed, and then we had like a locking mechanism that would like passively grip onto the rung, and then we'd pull ourselves up. However, because there is a high rung here, currently what we're thinking is that both of the arms are rotated by the same rotor, so they rotate with each other. However, extension is being controlled by two separate motors. So something that we are potentially thinking about doing is that we're going to add a small plate to the bottom of the chassis, like to the back of the chassis, so it automatically straightens itself on the base of the submersible. And we're going to extend one arm, which will hook onto the low rung. And then our belting system is very, very strong. Like it can sustain a solid amount of weight. We are going to extend the secondary arm and allow that to pull itself up to the high rung as we will be off the ground.
So
That is one of the ideas we are conceptualizing right now. However, if y'all have suggestions, we are so open to them.
So you have the one arm grab, and then the other arm grab. Then you
Yeah, the second arm
release.
can't grab until the first arm has gotten the robot at least entirely off the ground.
Okay, so then it gets up there. Then you reach out for the next one, let go of this, and then pull it up the next one, or else release and then pull the other one, pull both down. Okay, would be my thought.
Something along those lines.
Yeah, it sounds like it would be feasible.
To get the high rung, you also have to be completely like you can't have any contact with the low rung either. So you have to be completely above. You have to be completely above the low rung and like into kind of like the airspace of the high rung, I guess I'd say, to get those additional points. It's complex, and it's not something that a lot of people have achieved so far.
I was going to say, it's the rate, pull factor, when to grab, basically, or hook.
I'm curious. Once you've started to lift your robot off the ground, how do you maintain the orientation of the robot in terms of knowing where it is, knowing its pose? It must no longer be level, for example.
It's practically swinging, so
it's dangling. It's perpetually dangling.
The biggest, like, basically the loophole we're looking at right now is just the fact that so I'm gonna go back to the oh goodness, I'm gonna have to find that. Okay, so I'm gonna go back to the submersible picture again. So I maybe you can see, but in the bottom there's a little like rod, like a barrier, if you can see it.
Yep.
So this little barrier here, it's off the ground probably like an inch and a half, and then it's basically like a little metal piece. So once again, the caveat about getting the high rung is that you just need to be off the ground. So if there's a way for you to maintain your position for that like inch and a half when you get off the ground, and you can maintain like that like completely vertical position where the base of your chassis is completely parallel to the ground, and then that's the point from where you extend your second arm up. We're thinking that's going to allow us to remain vertical for enough time to initiate contact with the high rung and just pull ourselves up from there.
Right. Yeah. Okay. Thank you. That's
and
good.
That entire time, the back of those slides is in contact with the lower rung as well. So it's enforcing the verticality, or parallel to the ground condition, all the way up until you get higher than that rung. And then it doesn't matter as long as you don't let go of the bar, right? Because then you can swing. Then your robot will want to swing inside, but that's allowed by the rules. And as long as it doesn't let go, which a lot of teams have done that. It's like that's one of the failure modes. But they know how to create latching claws and things like that. So that's probably what they're going to do.
Thank you.
And they do have the ability to detect their orientation anyhow, because they have multiple IMUs on board.
So I assume the latching thing would be sort of like a Roby the Robot, Lost in Space type pincher-like thing. Is how
they have a ratchet and Paul kind of thing, so that they have they've created a locking mechanism. Like they used that last year. So
Okay,
it's actually sitting in a box downstairs, and it's
okay.
I
So
can
then,
use that again.
so you're going to have two basic arms. So where does it sample the block? Okay, I don't understand this picking up the block or how you're going effectively. You have a sampler shoot like boss thing. So how does that fully work? Is it how you push one into the sampler and only one can be in the sampler at a given time?
Only one sample or specimen can be in contact with the robot at a given time.
But
So-
there's fine points to that. Willie, so-
There are fine points to that. However, at the league meets that we've been attending, judges haven't been adhering to that. I mean, technically, you're allowed to have contact for I think up to 3 seconds with 2, just because you're in a submersible where you you're literally digging through a
Pile of them.
whole
Yeah.
bunch of samples. So you're allowed to have contact with 2 for I think up to 3 seconds, just because of the way the game is set up. However, you're not allowed to have 2 in your robot or in control of your robot.
Right, it can't be in the machine or grabbed by the machine. Effectively.
No, so something which happens actually sadly often is that if this is one of the problems we were having with the old sampler. So with V3 of the sampler, the belts were so loose that they couldn't maintain their grip on the samples well enough. So they had accidentally dislodged within our robot. And if they dislodge within the robot, there's absolutely no way to get it out of the robot, and then you're essentially useless for the rest of the game because you cannot do anything. I mean, you can do loopholey things, but you
Well,
can't.
are you taking
legally
care of
do
that by a strat or something to kick it out if need be? Or have you thought about something like that? Since it sounds like a high probability of that.
If the sampler is tensioned properly, which it seems like it is, because having too much, because the problem we were having was that it was tensioned too much, or
Right.
the beater bars were too stiff. So we are, at least right now, we are under the impression that we're not going to be having a dislodging problem again. But if it continues to occur with this version of the sampler, we're going to have to look into other solutions.
Or else figure out a way to have it basically spit it out or kick it out. A reversal type thing would be my thought.
It's not an issue when it's inside the sampler. However, if you look at the robot itself, there are plenty of places where a sample could accidentally fall in and then get stuck, and we can't control that much area.
But yeah, you were saying basically building shields around the motors and stuff, the reels, right? Yeah.
Yes.
Yeah, you can build a top cover or something.
Yeah,
but
you
it's
might.
got a lot of interactions it's got to avoid with those arms and such.
I know. That's why I'm like, yeah. You don't have a picture of the actual where you go into the. It sounds like just a pile of samples, and you have to sort of dive into it.
Do you have a picture of the loaded sub?
I can. It's kind of. I don't.
You can sort of see that. Yeah, see how many all of those little rectangles in there? Those are all samples.
So you
It
drive
is completely full of those things.
So you drive into the pile trying to figure out which color you want most of.
You drive up to the barriers,
Oh, the
essentially, which is
barrier.
You're not allowed to drive inside.
Into it. Okay, good. That solves some of the problem. I was wondering how you only touch one. To answer that. Okay. So your sampler is basically a tube that goes hover over one of them and spits it out or gets it.
Yeah,
Okay.
and contact is much more forgiving. They allow more contact inside the sub. So, if you hit a few, that's fine. But you cannot pull your opposing alliance's color out. That would be foul. So that's why they have a color sensor on it. And what it basically does is it keeps ejecting it in the same direction that it's pulling it in, or the opposite of it. So it ends up leaving the samples that it's okay to temporarily pull in opposing alliance sample because we don't have any control over that process, right? but the color sensor detects it's the wrong one, and it just keeps that belt running and ejects it.
Right.
It doesn't stop it in
Right,
there.
spits it
Yeah.
out.
Yeah.
Okay.
And it leaves it pretty much where it started.
Right. Well, in the
Just
box.
just aligned differently. Yeah.
Right. Okay. Oh.
Any other questions?
Only thing I can say is when you've got reverse of the side walls and that, and sounds like you need to reinforce the wall a little bit so it doesn't bend, if you can, type thing, and adjustment of the sampler tube, basically.
I got a question about the event. When do y'all have these competitions, and are they open to the public?
So historically, y'all have been some of the judges at our tournaments, like
Yeah, I almost was once. I got sick one year.
but yeah, they're open to the public. You can watch the matches. They are so the league tournament is February 1st, and then regionals is 2 weeks from that, February 15th. And they're all-day events. We'll get there at like 7, 8-ish, and we'll stay there till like 8, 9-ish as like award ceremonies happen, etc., etc. So, and match play is like for around like half of that time, because there's like, gameplays for around half of that time. So you get to see like a lot of other really interesting robots as well.
So
You can also watch them online at the First in Texas YouTube. They stream them live, and then you can also watch replays of them later.
Okay, cool.
Do you have a web address? You might post that to our chat?
Post what?
Post that to the chat. That spot that you said, could you see it online?
Oh, sure.
Yeah, I might be interested in going and watching that. It sounds pretty cool to watch, actually.
Yeah, it's a really intense experience at those competitions. Man, y'all just go hell for leather, give it everything you got.
So you're saying that you're going to be on the 1st and the 15th of February, it sounds like?
Definitely on the 1st. We have to qualify for the 15th before we can
Right.
participate.
But the key is they're going to have this 1st and 15th. And then after the 15th, is there any others?
So there are a lot of them. These are just the ones that we're participating in. There are these events like all over. Like I think there's one like probably at every weekend from this point onwards. You can find that information on the FTC website, on the FTC event manager, I think. And most, if not all of those, are also streamed to YouTube. So if you just want to see kids and their robots, that's all available there.
So the two spot. So on the 1st, which place are you going to be at? What high school? Or usually they have it at high school.
UME rep, right, Mr. V?
Yeah, on the 1st, February 1st, it's at UME. It's down south, sort of near my house. It's near Duncanville.
Okay.
The other one, the regional championship, is more up around Louisville.
Okay. But it's on the website. So if we went to look, I remember the one I was up when it was up. I don't know if that was, I don't think that was regional, or I don't know. But I remember one time it was up at Denton. There was at the college there, and then of course they had it at the convention center downtown. But I think that was,
that was a while back. Yeah.
Oh yeah.
So do you pick up a sample out of the submersible zone and then take that sample over to the net zone or the observation zone, and then go back and get another sample? Is that and rinse and repeat?
It's that, or we can go to the observation zone, get a specimen that our human player has set up from there, and then deposit that in the submersible zone on the chambers there. So those are basically our two. They're the two actions that we can do: samples or specimens.
So of the two, which one is easier for you all right now, or have you figured out, is there a difference, enough of a difference to make it worthwhile to concentrate on the one versus the other?
So we have significantly more experience with the samples, just because the sampler was something that we prototyped earlier on compared to the speciminer. However, on our next robot, with the speciminer, we've seen that it can grab specimen incredibly quickly. And we want to get actual on-robot testing of that to verify that it's something that we can start getting ready with, especially as we get the second arm ready to mount onto our current chassis. So if it goes the way we're expecting it to, or the way we hope it does, expecting is far out of the question, then we're going to try to fill up the high basket, which you can do with around like 15 samples. And then we go for specimen, unless we've seen like actual like data that specimen are faster, because specimen gets you 2 extra points per comparatively.
So yeah,
The reason you have to do both is because you don't know who you're going to be paired with. Your alliance partner may only be able to do one or the other.
Right.
And to maximize your score, you want to be the team that can do either or.
Right. You can't add to the value. Yeah.
Right. And there's a lot of congestion in the way these challenges are designed if you try to do this, both do the same thing.
Yep. Yep. Yes, interesting. It sounds like definitely an interesting year compared to the other years. Yeah.
Wow. I take my hat off to you folks.
Absolutely.
Challenges.
They come up with some interesting challenges. It's yeah. It's yeah.
They do that. Well, thanks for your input, guys.
Thank you for showing us what you're working on, and
thank you for showing us.
Sounds like they're all have planned well, and I really can't see too much improvement. Everything. It sounds like you may want to look at, your sampler in the walls so that it doesn't bulge or kick out type thing.
I just want to be able to run my robot in a straight line.
Right, Michael? One of our challenges look trivial compared to what these folks are doing.
Hardly.
Thank you all for giving us your time. We really, really appreciate it. And we also really appreciate your
Anuhya.
comments.
Thank you, Fernando, Saul. Appreciate you coming.
Excellent, guys. Thank you.
Very good.
Thank you so much, guys.
Wow, that was pretty neat. Okay, next up, we have Mike. Are you around and available, Mike?
Yeah, I'm here in the space. We're finishing up some tech cleanup. About 8 hours of it. so the next show should be even cleaner than what we had before. Can you hear me?
Yeah.
Yes.
And
was Elm there tonight?
Oh no, this is just tech. No actors. They're too distracting. Yeah. they want all the attention, and we needed time to ourselves.
One of the actors is one of my students.
Oh, yeah, she's great. Yeah, you could.
Elm Watley. Yeah.
Yeah, there's some silks you can see hanging from the ceiling in my picture.
Yeah.
You might want to pin this, but yeah. So Elm goes up the silks and comes down.
Oh, really?
Yeah. And she does it quite a few times, so she must have built up good muscles. Because that's like 16 feet, 18 feet in the air. So,
that's the thing where they roll themselves up in it.
Yeah.
To ascend. Yeah.
Yeah. So that's one thing that happens on the side. This room, I like to say it's the size of a football field, but I think it's something like 200 and 10 feet long and not 300. But so you can sort of see it, and the ceiling is the beams up there. Can't see them very well, but all of our lights and speakers are mounted up there, and they're 18 feet in the air, and the ceiling is 24 feet. So this place has a lot of echo.
So this building is the building up front of the fair part on the left, sort of on the left side where it has the fountain in front of it.
Well, this is the butter sculpture building, isn't it?
This building is next to the Hall of State.
Hall of State's next to it.
So it's like in the middle on the left side.
Okay.
Yeah, looking at it from the front. Yeah.
So it's on the left side. Well, you have the Hall of State building, and then they had the food court thing. So it's in the food court? In other words, let's put much different. There's nothing.
This is the one where they have the butter sculpture every year.
It could be.
Okay, now that helps. Once you say that I can zero in because, yeah, there's nothing in there right now. And it's hard to know the buildings when there's nothing in the.
Right.
Okay.
So it usually has a bunch of booths in here.
Right.
People sharpening knives and stuff.
Right. Okay. Yeah. And in the front, there's that little puppet theater like thing. Okay. At least I'm thinking that's the building. Okay. Cool.
Uh-oh. So this is the robot platform. And she greets people and talks and interacts with the actors. So she became a character, and we have a college student driving her. So he's gotten pretty good giving her emotions and stuff. I mean, now, like here's the controller here, and a lot of people have seen this at the at the show. Let me see. Oh, the battery's dead. It's been so long. Okay. It's been a long day. The battery died. So no movement. But
you charge it hopefully before the show, right?
Oh yeah, the show's only a couple hours, or I mean, from pre-show to show is only a couple hours. It's been on for 8 hours, so.
Wow.
So your robots have survived the stress of performance and kept working?
Oh yeah. And what? And like here is the like you can see there's a bunch of projections. Yeah, and so you can see there's like screens of projections everywhere. This is the musical instrument stand. So we have musical instruments going on, and you'll like this over here. I'm walking. It takes a long time to walk anywhere in here. Yeah, it was pretty dark over here, but this is the projection computer. You can't really see. There's no light, but we got all the HDMI cables going to all the projectors from this computer here, and this is the software that's running everything. So you can see in the back here, it keeps going and going. So it's a big space. There's a bunch of wireless mics and everything. To cover this big space, I had to get a pretty decent set of wireless mics. The ones that we had didn't have enough range. And so this is the rack here. It's hard to see. I should turn the lights on. but you can see some equipment on the rack. And it goes up about 10 feet to get the antennas all separated. But So it's been a production here trying to get it running, and we've had 2 shows and they've been doing okay, but the tech team decided we need to make it easier to run so that there's less errors during the show. Most of the people at the show don't really notice the errors, but we do. And it'll be a lot smoother, next weekend. So by Sunday, this is going to be a smooth as butter show.
And has your soccer ball been driving itself around like it should?
Yeah. So I'll go into the back room here where we charge up everything. Let there be light. And so this is my charging table here. So we got walkie-talkies, and then some big batteries for some balls, and these are the ball robots right here charging up. And then we have a bunch of batteries and chargers here, and then our wireless equipment are these with their microphones and everything. And then the soccer ball. Let me see. Open up the soccer ball container. Yeah, so they are, acrylic balls that were painted, and then we put them together and put the ball inside of it to make it run.
Right.
Neat.
And it's been running pretty. I mean, I think I demonstrated it once or twice at the place at our live shows, but everything's working. So, but it can always be better.
So
awesome, Mike, I'm really looking forward to seeing this.
You're having it Sunday at 4, and you can get tickets online, or
at
the door.
I posted the link for tickets at the beginning of the chat.
Yeah. So the link with the tickets and everything has a map of Fair Park, so it shows you exactly where it's at. But if you want to get it want to buy at the door, just come to the door.
Okay, so it can be either.
And
you
could, if anybody is a senior on this call, you can get a discount.
Either way.
Yeah.
At the door or online. Okay. And then the other thing is, do you actually drive down there, or are you taking DART? And there's parking down there.
There's good parking in the parking lot.
And so you park on the front, back, side, or?
Well, you come into gate 3, which is just off of the main street in front, and then there's a big parking lot for gate 3, and then right off the side of that parking lot is the building.
Okay, so basically over by the where used to the trains were, you're telling me. I think it's gate 3.
Yeah.
Okay.
Yeah, where the trains are.
Yeah, how much are they charging for parking?
Nothing.
Ah, okay.
Right.
Okay. Okay.
Nothing extra.
Okay, because for the fair, I think it was like $30 to park.
Oh yeah.
There, some outrageous number.
Right.
Times they'll charge like 20. So that's why I was wondering, because normally what I wind up doing is I take DART down there on the green line. So hence that's why the question, take DART, or do I do park and drive? And they're pluses, minuses either way.
Right.
So
yeah. So the parking is easy, and there was a big show last Friday across the street, and so the parking, they use a lot of the parking lot, but there's still lots of parking available.
Okay, so you haven't had any problem with parking or that? Okay.
No, you can fit hundreds and hundreds of cars in that parking lot.
And the show's not selling out?
No, it hasn't been selling out. That's unfortunate. Hopefully the word's getting out more and more people will be coming on. So, but we've had, the first 2 shows were pretty good.
So if you had written it up
like
on
six-
channel 4 or that, you
Pardon?
might. Well, you said get the word out. I was thinking like channel 4 or something like that. Where
Oh,
you know, those broadcasts
yeah. Like
events.
we put a link on there which was from KERA, and then
Well, I
and,
saw that. But
and then
yeah, I
Dallas
didn't-
Morning
right.
News had a whole page article in their
Okay.
and I'm hoping that I haven't seen any TVs, but I would hope that it'd be on the TV.
Right.
Oh, the show notes say that audience participation and interaction is encouraged. What form does that take?
Oh, it's just
Yeah.
getting closer to the action, and
Is
if
it
you
one
feel
of these how the robots type thing?
yeah,
Or
you can't
pitch
get
the robot? Oh,
you can't get in everyone's way, but if you're in the way, they go around you and stuff. The actors.
oh, that's good.
And then the what am I trying to say? Oh, and then there's 3 meditation periods where you're encouraged to meditate for a couple minutes between scenes. They're pretty intense, the scenes are. And so there's like these big intense scenes and some meditation, and then some more scenes and meditation. And that's basically the instruments here are puts out the nice sounds for meditation. But the gong also is when the bomb explodes.
Oh. So you're saying we might want to bring earmuffs along?
Spoilers.
It's not that loud.
Okay.
Yeah. But yeah, so it's been an experience. I'm hoping to get back into my robots building, but they're trying to get funding for a show to take the show to Chicago in the summer.
Ooh.
So it might mess up my robot stuff. Darn stuff it messes up my robot stuff. But the show the second time be a lot easier than the first time. So
We learn curve, yeah.
yeah.
Wow, Mike, that's pretty cool.
All right, so that's what we're doing. We're about ready to wrap up and go home.
Yeah. So
Well,
one sub-question while you're at it then is, so there's security around there, I assume, right? In the parking lot and that.
Yeah. Oh yeah, there's security all around. But and I'll
Oh yeah, I usually tend to go when the fair's running, so there are a lot more security and people.
yeah during the
Okay.
during the fair there's a lot more security.
But okay.
But if I look out the door here, let me see, trying to go to the door. Like I said, it takes a long time to go anywhere in here. 100, 200 feet.
This is not a small building.
Yeah. So you can see the parking lot there.
Okay. Yeah.
And my car.
Oh, so you actually park where? Okay. I was beyond the fence there. Okay.
Yeah.
Okay. Right. So you're actually parking relatively close.
So you can see my car right ahead.
Right. Okay.
Oh, the only 2 cars here. Me and my colleague.
Okay.
All right.
So thanks for the fee, and then we'll let you go.
All right. Well, thanks for listening.
Hey, appreciate you introducing us to it. I hope we get some of the club come out and support you and see what you've been involved in. It looks pretty neat.
Yeah, the little kids that come here, some of them they're like 6 years old, 7-year old. They really love the robots.
Yeah, I bet.
Yeah. All right.
Hey, thanks, Mike.
Okay.
Take care. All right. Well, that was pretty cool. So that brings us to the open mic section of the meeting. So I guess I'm going to kick it off and with a question. Does anyone know does PLA shrink or expand when you print it compared to the design dimensions? Because
Shrinks a little bit.
It what?
Yeah, but
I
I don't
think-
know how much is the key question.
I think it shrinks a little bit. As far as I remember, I wouldn't be exactly sure as to how much, but I know someone who does.
Whenever I print with stuff, either here with my printer or the one at the at Mr. V's house, we do probably 3.5 for 3mm holes, or at least 3.26. That would be for like if you want to do threaded, but we do 3.5 just to be sure, so that they're fully through hole.
And
Well, that
then
may be a different question because, Paul, are you talking about overall dimensional shrinkage, or are you talking about crowding in holes?
overall dimensional shrinkage, because I've got two slots that motor mounts fit in, and I had I think about 0.2 millimeters of gap between the holes that are cut in the chassis. So so these, let's see if I can point them out. These holes, there's a little acrylic thing here, but when I printed out the motor mount, that's actually, I'll show the other side of it. When I printed out the motor mount, which I designed, 3D printed it, and I've designed it to be about 0.2 millimeters smaller than the width of the slot that it fits through. It didn't fit, and it was about 0.2 millimeters too wide.
Yeah, but
So
there is fingers.
So that's more of a
lost a bunch of people
Oh yeah,
in the
or not, they will.
hopefully they'll rejoin. So Kareem, you are about to say something about my slot size versus the motor mount size and shrinkage.
so I sort of see PLA as fairly dimensionally stable. What you may have is I don't know if you've like compared it versus metrics. Like what tends to happen is the travel in either the X or the Y direction for your printer may need to be recalibrated. That's one thing. The other is that different slicers will handle internal voids differently. So you're talking about a slot, right?
Yeah.
Which is similar to the hole problem, right? So some will end up crowding it, so there's more material there than is accounted for, and so they're actually smaller slots or holes than you specify in the dimensions. And one of our standard processes that we go through is we always have to redesign for manufacturability. Right. So whether we're doing CNC, like even on the CNC, if we're doing carbon fiber, we know that carbon fiber will relax a little bit and then it'll come back into the hole after the cut. Right. So it can be pushed away a little bit and it can relax. So we actually have to make our dimensions a little bit larger on interior voids, even on carbon fiber on the CNC. And each of our printers behaves differently in terms of how much it crowds, depending upon what tool chain we use for slicing. And so we have to, if we're really concerned about fit, it's never the actual design dimensions. We have to reprint it. We have to redesign it for the, the device we're using.
One computer may be a little too big and the other one a little too small. That they're
exactly, yeah. That's what's going on. And outer dimensions get treated differently from inner dimensions. Right. It's usually the inner dimensions that get crowded a little bit.
Yeah, that's exactly what happened, because my slots were specified as 12 millimeters, and they actually ended up 11.6 or thereabouts.
So that's a pretty big variation right there. So you may also want to double check your calibration, right? So have you done a calibration cube? So those are generally good for outer dimensions, but that sort of tells you if your if your travel of your X and Y travel are correct.
I don't think I've done a calibration cube, so I'll do that. Thank you for that tip.
Usually what I do is print the thing out, see if it fits. If not, then scale it up or down accordingly. Especially I get, a file from somewhere else.
Yeah, sometimes there's a little bit of trial and error. Right.
Okay.
Yeah,
What
and-
type of printer do you have?
An Ender V3.
Okay. Yeah, I put a link in there for Bamboo, but I'll look for one for Ender. And there's usually a setting that you can compensate for the size of the holes.
Oh.
Yeah, and each
Yeah.
slicer is different in how they do that.
Yeah.
Yeah, I'm using Cura for a slicer.
We use
Well, thanks,
Cura.
guys. I've got a couple of directions to go here. Appreciate it.
Sure.
Who else has got something for open mic?
I can show one thing on Thingiverse, but it was just mainly a cover thing. At least I think I have it set up. Yes. So yeah, I'll show you that. I thought it was sort of nice. And let me get back to where I was. Okay, there's us. Share. Pick the tab. Well, there was this. If you like Doctor Who, you can basically build a roll cover to go over something that Paulus looks like it's building roughly in my mind. Anyway, there's a Doctor Who cover if you're into covers. Speaking of 3D printing, well, there's that. And let's see, stop share. Okay, so that covers that. And I don't know if there are or not. I saw that's a plate thing that they can put on their robot if they wanted to. It's on Thingiverse. I'll just put it in the chat in case they wanted that. But they probably have a plate for their robot already, is my guess. Unless we want a plate for our robots, I'll just share it. And I might as well just, I'll show you that. In case somebody wants that. See, that would be plates. So there's that little thing too that they have for plate. So if we want a real license plate type thing. Well, those are two things I found. Beyond that, I don't really have very much else at this stage.
Hey, Paul, like they were saying about your 3D printer parts, you can, just do a sample and then see if it fits. But like when you're doing little holes like this or whatever, you can just, if sometimes they're too small. Normally mine print's too small for holes, so you oversize them in the code when you're drawing them up. It's 3 millimeter, like the one guy said, 3 millimeter. You might want to write it in your modeler as 3.5 or 3.2 or something. But a lot of times I got a drill press over there. I just drill a hole out if it's a little bit tight, or ream it, or just get some reamers and just ream it out. It's for holes, for slots. For slots, ain't much you can do about them. They're
Right.
They are what they are. Unless you want to get a Dremel tool after it.
That's why I said at that stage I just rescaled the whole mold.
Yeah, I just rescale the thing.
So
a lot of times. Matter of fact, I did that tonight on me.
or whatever.
Dremel tool's a good idea. Thank you for that, Michael. I'll get after it with a Dremel.
Yeah, especially if nobody sees it, you cover it up. Who cares what it looks like, right? So Dremel tools can looked pretty goofy at the end of it. But yeah. Anyway, yeah. I've got the. Let me show you something while we're just doing nothing. I've been a machinist my whole life. So, but when I retired, I think I showed y'all last couple of years ago I got a little shed out back. I got a little bitty bench top lathe and mill back out there. And what's nice about doing that is now that I can do this for fun, like I needed a hub for this timing gear or pulley I made. And PLA is not very strong, so I made a little hub for it. See that? And I did that back in my machine shop out there. So that's real nice to have. That way, when I mount this inside that PLA part, I've got something to that won't strip out on the bore there.
Nice. Yeah.
So that's I'm kind of proud of that. Or it's fun to have that, that access that I have to that. That little machine shop helps a lot. I'm messing with this claw machine. I'm still messing with it, and I'm making a lot of metal parts instead of plastic ones, so they'll hold up better over time. So, all right.
What kind of mill and lathe do you have?
I got a little bench top. I've got it on. They're just little. You've heard of V-bores?
Yeah.
It's just the V-bore stuff.
Okay.
Real cheap stuff. My lathe is I think was $600 or $700, and the little bench top milling machine was about $1,000 bucks.
Mm-hmm.
And they just sit on top of a table.
Yep.
Maybe I'll post that in the notes there for you. I got a YouTube video of just walking through my little shop.
Oh, okay.
That'd be nice.
So, yeah, I'll kind of try to post that before we get off.
Yeah, if you could post that, I'd like to try and keep the Facebook channel, populated with a bit of activity now and then. Try and do a post every week or maybe a couple of weeks, and that's the sort of content that's fun to just put up on the DPRG Facebook channel.
I'm going to show y'all a little scan of my little. Okay, here it is. I'm fixing to post it. If I know how to do it right. There we go. There we go. Y'all can look at that in your spare time, or we can view it if you want to. I don't know how to. Huh?
Yeah. Why don't you display it and?
I'm going to start running. How do I present that page?
So there's a box on the row of buttons at the bottom of your window. There's a box with an up arrow in it. That's the present. So you present your window
Screen?
or your probably a window, maybe a screen, depending on whether you're going to show it full screen. And then you just start playing the video, and it should come through. Normally, sound won't come through, so you might need to narrate it.
Okay. I think that's it.
There we go.
I'm going to show you all a little scan of my little shop. Let me do a scan. There's a. Y'all seeing it?
Yep.
Belt sander. There's a saw, bandsaw. There's my milling machine.
Ooh.
I know it's still a mess, but
nice.
I'm just now getting back into the energy to do something. There's a work table that's dirty right now, but I can clean all that off and lay stuff on it. My computer chair for sitting down a lot. There's some shelves and some more shelves. There's my welding table. And I'll be cleaning this up pretty soon. I finally got some energy to start doing stuff after a few weeks, a couple of months of R&R. All right, I'm done.
Nice, Michael. Thank you.
You bet. Let me unpresent. Stop presenting. There we go. Uh-oh. We got other junk going on here. Okay. But that's what I got. And I have a lot of fun with it. So
Nice.
yep.
Well, I'll tell you what, it feels like we're losing momentum and we lost half of our audience. So maybe it's time we call it a night.
Right.
All right. Good seeing you all. And think about coming down to Mike's play and Mike's theater event. I'm going to post that video segment out of the meeting in the email chat along with a link, and I reckon it'd be pretty interesting. I've never done anything like that. I think it'd be cool. All right, everyone. Good talking to you. Talk to you later.
Night, guys.